Hello bachcho, let's see the question. So here it is saying that if Z1, Z2, Z3 are the vertices of an equilateral triangle whose orthocenter is the origin. ठीक है, तो हमें दिया गया है कि Z1, Z2, Z3 जो है वो वर्टिसेस है एक इक्विलेटरल ट्रायंगल का एंड उसकी ऑर्थोसेंटर ओरिजिन है. Then we have to check these options which is correct and which is incorrect. Okay, so to solve this question, we should know some key concepts which are as here. So key concepts में हमें सबसे पहले पता होना चाहिए properties of triangles, types of triangles, उसकी ऑर्थोसेंटर क्या होती है, उसकी सेंट्रॉइड क्या होती है. ओके, देन सरकम सेंटर भी होती है, बहुत सारे सेंटर्स होते हैं. सो वी शुड हैव द बेसिक आइडिया ऑफ इन सेंटर, सरकम सेंटर एंड ऑर्थो सेंटर of equilateral triangle. Then complex number and cube roots of unity. Okay, so with this we can solve this question. So I'll give you a brief on it. In a equilateral triangle, how it is making a orthocenter. Okay, so I'll make a triangle to make you understand for orthocircle. So I will again make it here, and one we will take it here. So it's just an example. So here there is, let's assume this is a equilateral triangle of A, B, C points. Okay, and these points are Z1, Z2, Z3 as it is given in the question. Now what will be the centroid and orthocenter of this triangle? So we have to find orthocenter. Then we will do what? We will make a perpendicular from each vertex. Okay, so we have to make a perpendicular from each vertex, and these vertex will definitely coincide at a point, at a single point. Okay, and this single point is our orthocenter for this particular triangle. This point will be our orthocenter, this point. Now in this equilateral triangle, this will be same for orthocenter and circumcircle, or you can say centroid. So this point is origin given. So in this way we are finding the we can say orthocenter in a triangle. Now cube root of unity. What are the cube roots? So cube roots are basically, we are finding a cube root of 1. So it will be having 3 numbers which we are assuming as 1, omega and omega square. Okay, so these are the cube roots, and there is one condition that 1 plus omega square is 0. Okay, so we will use these conditions to solve this question. So here we have our triangle, equilateral triangle I am making, and in that we will be having a Z1, Z2, Z3. Okay, just a second. Okay, so I am again taking this line and we will make one triangle here again. Now we have to draw the perpendiculars. So I will draw the perpendicular. from each vertex to the opposite side. Just like the same figure, and assume it that it is a equilateral triangle of Z1, Z2 and Z3, and this one is the orthocenter, which is origin. So in equilateral triangle, orthocenter and our centroid are same points. Okay, so if orthocenter is origin, obviously the centroid, we can denote centroid with G, is also at origin. It means the point coordinates will be 0, 0. So if I will find my centroid coordinates with help of this triangle vertex, so it will be like this. G will be equals to Z1 plus Z2 plus Z3 whole upon 3 is the coordinate for centroid. But we also know that centroid is given at 0 origin, because this will be same for orthocenter, and orthocenter is origin. Okay, so from here we can conclude that Z1 plus Z2 plus Z3 is 0. So this is one thing which we got. Now it is looking like same, just an equation we have studied of cube root of unity. Okay, so here if you will assume Z1 as 1, Z2 as omega and Z3 as omega square, so we can easily conclude that it is making a condition or satisfying this condition of 1 plus omega square equals to 0. So it is satisfying this condition. We can assume obviously that this Z1, Z2, Z3 are cube roots of unity. Okay, now we will check for the options given in our question. So the first option was Z1 plus Z2 plus Z3. This was correct. Now we will check for Z1, Z2, Z3 magnitude. So as you assumed here that Z1, Z2 and Z3 values are 1 omega and omega square, we will find the magnitude. So magnitude of Z1 will be 1. Now magnitude of Z2 will be magnitude of omega, and omega is what? Omega is cube root of unity. Okay, so definitely this magnitude will also be 1, and Z3 will be again omega square, so its magnitude will also be 1 only. Okay, so in this way we can also say that these values are correct, equal, and that is why this option number B is also correct. Now come to C. So Z2 Z3, Z3 Z1, Z2 Z3 plus Z3 Z1 plus Z1 Z2. So we will put our values of omega 1, Z1, Z2, Z3. So omega into omega square plus omega square into 1 plus 1 into omega. So it will be omega cube. Okay, so now omega cube will be obviously 1, because omega is cube root of 1. So definitely omega cube will be 1 only, and here is omega square plus 1. Sorry, here omega. Okay, so now if I will take it in a box and I will re-simplify it. So omega cube can be written as 1, then omega square plus omega is equals to 0. So it is satisfying. LHS is equals to RHS, because in our equation it was given in option number 3 this thing, and we have to prove it equals to 0. So we have proceed with this and we have proved it that it will come equals to 0. So that's why option number C is also correct. Okay. Now let's check for option number D. So OZ1 is perpendicular to Z2Z3. So let's again look at a figure to make it more clear. OZ1 means this line. Okay. So this line is perpendicular to Z2 Z3 means this one, the bottom baseline. So if this is the base and this is OZ1, we have to check that is it perpendicular or not. So definitely this O is what? O is orthocenter. And orthocenter we are getting only when we are passing the altitudes from each vertex, and this common intersection point is our orthocenter. It means this OZ1 will be an altitude, or you can say perpendicular. So definitely this is a perpendicular line to Z2 Z3. That is why yes, OZ1 is perpendicular to Z2 Z3, and hence our all options A, B, C, D are correct. Okay. Thank you, बच्चों.